All right, let's go ahead and officially begin this course. So for those of you who don't know me, which I don't think is any of you, I think you all know me, my name is Mr. Tesler, and I am the instructor for Math 3733, Mathematical Computing. Happy Wednesday, Happy New Year, and with every course I like to always start out with prayer. So let's go ahead and do that, and then we'll talk about what we're going to do today, and we're going to go ahead and get started. If anyone's having issues getting logged into computers, feel free to move around. I think, Anna, that's maybe why you moved. So make sure you get logged into a computer. We will be starting it today. Hey, Lois. Let's pray. God, I thank you for this day. I thank you for these students. And Lord, I just pray you'd bless this semester. I pray that you would just be with these students as they learn and grow and just develop their mathematical abilities. I pray that they would just find insight and that they would find joy in what they learn. Lord, I thank you for this time in this class, and we just give it to you. In your name we pray. Amen. All right, so let's start by looking what's on my fire and get registered for the platform that we will be using for the computing or the programming. So I'm going to start by just looking at my fire and looking at the syllabus. Is that large enough text for everyone? Everyone can see that, okay? Okay. So let's take a quick look at the syllabus and just look at what this course is about, kind of just what the projects are, how the grade breaks down, and the like. So the prerequisite for this course is Calculus 2. It is really more of a co-requisite. Really, the prereq is just to make sure you have enough mathematical maturity that as we discuss certain things like sums or iteration or and just have enough mathematical maturity that you can reason through the problems that we will encounter, and then be able to go ahead and provide some sort of program to solve those problems. So this course is designed for students with no prior programming experience. The course introduces the fundamental concepts of procedural programming, and many of the topics, especially later in the semester, are going to have a very heavy mathematical leaning, especially in graph theory, probability, and some simulations. Just kind of let me get an idea of kind of what you all know. Does anyone have any programming experience? Okay, Alejandro, I think I've talked to you a little bit. So I am not making the assumption that you do have programming experience. That's what this course is for. You'll find that is going to be very beneficial even in many of your other courses. I've found that especially in abstract algebra or number theory, when I was an undergrad, once I had some programming, I could actually think about problems a little bit differently because I had the tools to approach them in a way that I can maybe write a program to help me see the underlying mathematics. I think you're all going to really like this course. Y'all like solving problems. That's kind of the math major's thing, problem solving, critical thinking. But I found a lot of times, especially when it comes to calculus, you solve a problem and what you have at the end of that is a piece of paper with the proof, which is cool and all. But for this course, what we'll have when we're done are the precursor to things like Google and Instagram and all these things that we just see in our day-to-day world. So that's kind of like if you were to take these concepts to conclusions and truly master them, the things that you can do. So I think it's really exciting the things we'll create. So I would encourage you to read through the whole syllabus. A lot of this reflects very much what you would see in upper level math course syllabus, reflecting Dr. Geim's philosophies, and again, just to be consistent across it. The course workload, you will be expected to work outside of class, whether that's including reading, practice problems, and exercises. So let's talk about the readings first. I am recommending 2 textbooks for this course. The first one is Introduction to Computation and Programming Using Python. This one is out of MIT Press. It has a lot of more of a mathematical slant to its development of programming. So I say recommended because, again, there's so much out there in terms of just free resources, but sometimes people like the structure of going through a textbook, and all of the notes that or all of the ideas we go through in class, I will have in notes which will be provided to you. So I recommend that you look into that. I don't think it's too much. I think it's like $50. This is the one that I posted on the bookstore website. The second one is more of a kind of a computer science leaning textbook, Think Python. The second edition is by Alan B. Downey, is freely available on the author's website, so that's why it was not on the bookstore's website. I didn't want to cause any confusion. If you want a hard copy, feel free to order it. But you also can get an HTML version and a PDF of that. Think Python also has a lot more exercises that you can do. The Intro to Computation and Programming by Gutag is more exposition than it is problems. But honestly, I'll post more as we go. There's going to be some graded exercises, but there are websites dedicated to programming problems and projects and things like that. Some other supplemental resources is the official Python 3 documentation. We're going to be using Python as our programming language for this course. Python is an open source language. It's developed by some very smart people in the community. First developed in the 90s by Guido van Rossum. He just stepped down as like the head of the organization a few years ago. But Python is still a highly developed language, and it's catching up to the likes of some more historical languages like Java. Java just is still the most popular language because of a lot of enterprise systems uses those. But Python has a lot of functionality that we're going to explore, and is one of the most popular languages for programming today. So we will use Python 3.8. Python 3.10 is the most recent version, but the platform we're using only has 3.8. And honestly, this course won't even get into the kind of the advancements that are available in those extra two versions. So we'll also learn about LaTeX in this course. LaTeX is a typesetting language that all professional mathematicians use to publish. So we'll take about a week and a half and expose you to that. It is also, so like if you look at all those fancy math papers, it is typed using LaTeX, and it's a compiled typesetting language. So we'll explore that using some online platforms. The majority of the course we're going to be using REPL, so we're going to get you logged into that here pretty soon. REPL.it is an online web application that basically provides the compilers and interpreters for various languages. So any questions about the course materials? Okay, so the course topics, feel free to read through these. The intended learning outcomes are basically you're going to be learning how to program. The key performance indicators, so these are your assessments. So let's just pause right here, and I'll show you what these assessments are. There's going to be 7 projects this semester. They're going to be worth 10% each, which is 60% of the overall grade, because as you can see right here, the lowest grade of projects 1 through 6 may be dropped as long as at least a grade of 50% was earned. Each project is going to really enforce ideas from class, so I'm not going to let anyone just ignore a project. But I will kind of be like, hey, you had a rough week, maybe you didn't get 100%, but I wanted you to at least be exposed. Project 7 is going to basically be a make your own project, and there's, I think, a lot of learning that happens when you are not given any instruction apart from a rubric and some guidelines, and you have to create something that is yours uniquely. So that project cannot be dropped. That'll be at the end of the semester. I'll give more details on that as it goes. Programming exercises are going to be worth 10% of the overall grade. These will be assigned in class. I'll kind of show you where to find them, and I'll kind of assign the first ones to you later today. The midterm and the final are each worth 15%. There's only the 2 assessments in this course. We'll talk about them as they get closer, but they are outlined in the schedules, the tentative dates for those. So does anyone have any questions concerning how the grade is distributed through this course? Okay. The late work keep me informed if something is going on. And we'll talk more about the collaboration policy when the first project is released, probably more on that Friday or Monday. The rest of this is just going to be the academic policies for the university and the course schedule. Feel free to read through those, but the course schedule, I'm also providing a condensed version right here. So let's go ahead and take a look at this. And let's make that bigger because, or maybe I'm the only one that's bothered by the small size because I'm older, but I don't know. So you can see right here, this is the course schedule. Projects are going to be due about every 2 weeks. Those, I would encourage you to definitely read the assignment as soon as it's released and give yourself plenty of time to do those. Those are not going to be trivial, something you can sit down and do in an evening, especially if you are not used to programming or are doing computations with this kind of programming mindset. The midterm is going to be right before spring break. Any date labeled TBD meaning to be determined, basically that's just going to give us some flexibility. If it's one of those things you have questions in class, I want to slow down a little bit, maybe do an extra example, walk through the algorithm a little bit slower, that's why I have those days scattered throughout. Here it just gives us some flexibility with the schedule. So like this is a very tentative schedule. I do match my pacing to kind of what you are all understanding within reason. And then of course project 7 also can't be dropped because I give a week to work on it in class while studying for the final. So that is the kind of the logistics of the course. Does anyone have any questions on that? Okay, so what we're going to go ahead and do next then is we're going to go ahead and get us set up on the platform that we will use to code together. You are welcome to, of course, install natively on your own machine, but because there's so many different computer environments, we're going to just use a web-based platform. So in order to do that, go ahead and log into your email. And what I'm going to do is I'm going to invite you to our class section. This platform is free for you all. The university is paying for basically the educational side of it, so I don't even think there was a lab fee. So let me go ahead and get you all enrolled into this course. So go to your email, and you should receive an email with an invitation. Once someone's got it, let me know. If not, I'll just have to type them in manually. Any luck yet? No? Okay. Let's see. Let me try it one more time because it doesn't look like it went. All right, let's do it this way then because I don't think it's doing it. All right, so let me go ahead and do it like this. Generate team link. So go to My Fire, and I'm just going to create a link under syllabus and course. So course enrollment link. Let's do it this way. Manage team members. Copy. And paste. Let's try it that way. So go ahead and refresh the syllabus and course information on My Fire, and we'll do it this way. All right. Did that work?
Yes.
Okay. Yeah. So you're welcome to create your own login, or you can log in with Google, which your Southeastern email is Google. I'd always recommend that, just because you technically can get the 3 months of the paid version with your with an education account, but make sure you get logged in there. So, first question, do you all prefer dark or light? Dark? Okay. So I heard 2 votes for dark, and everyone else just looked at me like, I don't care. Okay. All right. So let's go ahead and kind of just get started with kind of looking at this platform and what we're going to be working. So let's suppose you just wanted to experiment a little bit, and as we go through class, this is typically the setup I'm going to go ahead and take. So I'm going to go ahead and click Create in the upper left-hand corner, and then it's going to ask me to select a template. I'm going to select Python. That's the one I'll be teaching on. But as you can see, this platform has their total count, but compilers and interpreters for a bunch of different languages. So just select Python. Do not select the one that says Python with Turtle or Pygame. We'll look at those later this semester. So Python, I'm going to just go ahead and name mine like day 01, so day 1. Feel free to name it whatever you want. It generates some goofy name. Does anyone still need more time getting enrolled into the REPL? Does anyone have any issues with that? It's still... Is it good? Yeah. Oh, you're just watching that one. All right. So you may just kind of miss a little bit of the first one, but we'll give you a sec. Okay, so let me go ahead and then hit Create REPL, and I'll go ahead and kind of talk about what we're going to run into here. So there's a lot going on right here. On the left is going to be the files that will be in kind of the environment we're working on. One other thing you'll want to be aware of, I'll talk about this, you'll see this more later. This little check mark is how you're going to how your programming exercises will be auto-graded, and I'll talk more about that a little bit later. Where you're going to write programs is going to be in this middle part. And then over here you have the console and the shell. I'll talk about what the difference between those are as we go on with today. All right, so let's go ahead and start by basically writing what is the quintessential first program for any time you're learning a language. And that is sometimes referred to as a Hello World program. So you'll find that as you go through tutorials, or if you're looking at any tutorials about a language, the first program you're going to write is Hello World. You're basically going to want to get the computer to talk to you. So what we're going to do is we're going to simply type the word print. Print is a function, and we'll talk about more functions as we go. Functions take input, so I'm going to put a parentheses right here. And what I'm going to go ahead and do is put double quotation marks. You can notice that this platform autofills some of the symbols that we type, and then what I'm going to simply type in there is Hello World. And then I'm going to go ahead and run this program. And again, we're going to just use this button at the top for this one, and we'll talk more about when you cannot and can use that. So right there, you can see on the right, the computer printed to the standard output, Hello World. So you just wrote your first program. Not much to it, but it does ensure that our platform is working correctly. Alejandro, are you good? Are you set up now? Okay. So, by the way, a couple other things that you can do. I can't remember what the default setting is. It might be enabled. So when you guys were typing, did you see something like this box come up like this? You're welcome to use that. We'll talk about this as we go. That's called code intelligence. What it's doing is recognizing how you're typing. And it's basically saying, hey, we think you're about to say, do this. I'm going to probably leave it off as I teach for at least the first part as we get the hang of the different things that we're going to encounter, from functions to how to program certain things. But you're welcome to leave it on. but just don't be shocked like when that pops up. That is basically just doing some prediction, but I'm going to leave it disabled. And we'll talk about, you can see right here, there's just a lot of information for someone new to programming. That's also why I'm going to leave it off, but it is basically telling you what this function can take as input and its documentation. So I'm going to leave that off for now. It's up to you whether you want to leave it off or on. Okay, so that is our first program. So let's go ahead, and before we do anything more, let's maybe just kind of get into a mindset like computation. What is a computer? So my recommendation is, I'm going to take notes as we go through class. You don't need to. I'll make these notes available to you afterwards. But just so you don't fall behind, the main thing you probably would want to be typing are the programs that we write. So over here, don't worry about where I'm typing as much as like what is appearing on the left-hand side, because it's going to format it much nicer. So the first question we maybe want to go ahead and just talk about for this course, it is called Mathematical Computing. So what is a computer? What do you all say is a computer?
A device.
So a device, like the one sitting in front of you, okay.
Something that has a fixed algorithm.
So something working with algorithms. And the reason I put this in quotes is because, did anyone see that movie Hidden Figures? Where the lady sent them to space. So when we think about like a device and things, so like you could think the machine in front of you is a modern computer, but the reality is you are computers. Now, preface that you are slow and have very bad memories compared to modern computers, but the reality is you are computers. The reality is, unfortunately, you are slow and have a bad memory. So what we have done is we have created devices that compute for us, that help us aid in computation. So we have created devices that aid in computations, and you can see we sent people to the moon in Hidden Figures, but you can now see, did anyone stay up or did anyone get up to watch the launch of the James Webb telescope over Christmas, on Christmas Eve? I don't know if you guys are aware what it is. We had the Hubble telescope, which was orbiting Earth, taking pictures of the universe. They just sent out a $10 billion telescope into the Lagrange point, that is it's a little farther. I think it's about 15 million kilometers away. That's going to take pictures of the distant universe. I don't know. That is exciting to me. Like the fact that we're going to begin to observe the reaches of the far reaches of the universe. But computers aid us in understanding the world and solving problems. So let's maybe, since we know what a computer is, let's maybe talk about what does a computer do? If I were to pose that question, what do you all say? What would a computer do? Computes. Okay, so it performs computations. You're like, oh, that was kind of the similar answer to the first one. Is when that computes, what does a computer do? It performs computations. But what is the other thing I emphasize that we're bad at? Memory. Computers are very good at remembering things. So it performs computations and it remembers them. So for example, you can do computer. I can be like 3 plus 3 is
4.
Try again. 3 plus 3 is? What? 6. Times 5 is? You're like, I don't even remember the question. So I think that proves, bad memory But it's one of those things, and you can just do a string like, okay, 3 plus 3 is 6, times 5 is 30, plus 1,000 divided by 5, consider the remainder. You've already lost what the number is, but again, it is storing all of those faster than you could even type the next command. So it performs computations and it also remembers computations. But here's the thing that is also really good. What does a computer do? What a human tells it to do. Tells it to do. So yes, it can do all of these computations and it has a much better memory, but the reality is it could only do what a human tells it to do. There was a cool quote that I saw. Let me go ahead and pull it up so I don't have to type the whole thing. So let me just grab this quote. I know that's a little small. I'll pull it over. Has anyone read Hitchhiker's Guide to the Galaxy by Douglas Adams? I highly recommend it. It's one of those, it's like, they talking about a probability machine. It's kind of a gimmick, but for the show. But the quote is this. Douglas Adams wrote Hitchhiker's Guide to the Galaxy. Dirk Gently's Holistic Detective Agency is another one of his books. And in that book it says, what I mean is that if you really want to understand something, the best way is to try to explain it to someone else. That forces you to sort it out in your own mind. You've heard the adage, the best way to understand something is to teach it, right? And then the second part is this is really what's more relevant to this course, and that's what the essence of programming. By the time you sorted out a complicated idea into little steps that even a stupid machine can deal with, you certainly learn something about it yourself. So that is starting to get into the idea that Andrea mentioned earlier is algorithms. So let's go ahead and just talk about a little bit of terminology, and then we'll go ahead and actually get into some programming as we kind of set up the course. So just a little bit of terminology to be aware of. So when we talk about computation, let me see if I can, hold on, let me do this to help you all that are sitting in back. How did I do this? There we go. Just figured for those of you in back, I didn't want you to crane your neck reaching over. Okay, so computation is any type of calculation that includes both arithmetical and non-arithmetical steps, and which follows a well-defined model, e.g. an algorithm. So careful right here, an algorithm is not a logarithm. A logarithm is the function that you talk about working with different bases. An algorithm is a sequence of well-defined steps. So the thing to note here, when we think about computation, we typically think about what we did earlier, just adding, subtracting, multiplying, looking at numbers. But when it comes to actual computation, there are some non-arithmetical things to consider, like where are you storing information? How are you combining information? How do you take different branches depending on the different information? And that's where we're going to get when it comes to understanding a program. So a program, let's go ahead and just kind of have that in the back of our mind. A program is a sequence of instructions that specify how to perform a computation. So when we say we're writing a program, we're just writing a sequence of steps that is telling our modern computers how to go ahead and perform a computation. So let's go ahead and just maybe play like a little bit of a game right here. So just to kind of, because it's going to illustrate a lot of ideas that we're going to learn about as we go through this course. So you can see I labeled it guessing game. So here, I'll spoil it. I am thinking of, let me spell correctly, of a number. Try to guess it. All right. I am thinking of a number. Who wants to try and guess it? All right, we have a vote up here. Andrea said 5, and my response to that is too low. Guess again. All right. McKenna?
Is it an integer or like?
Okay, interesting question. Is it an integer? So take your guess.
Well, I hope so.
So I am acting as the computer. So what's your guess?
100,000.
100,000. Okay. 100,000. Well, too high. Guess again. All right. So they didn't get it. Let's see who else wants to take a guess. Seth? 9. All right. 9. Guess what? Too low. Guess again. Who wants to? 15? 50? Okay. So 50. Okay, so you type 50, you input it. That's it. Would you like to play again? Please say no. But right here, this little idea illustrated so many interesting points. It also, you like, does it have to be an integer? Well, you could have tried it and you could have seen what would have happened. And of course, those are things you're going to have to consider as you write programs. Do you want to force them to tell you an integer? Do you want to go ahead and what if you guys guessed hello? Like, would I have crashed? Who knows? But those are things that you're going to have to consider as we write our programs. But there's a lot of ideas that are illustrated in this little game that we played right here. So some of the main ideas that are illustrated here here's an idea of variables to store numbers. What were the numbers being stored there? There were 2 types of numbers being stored, or 2 kind of what were those 2 numbers? Say again? Okay, so it wasn't so high and low aren't necessarily what was being stored, but that was type of a comparison between what 2 numbers? The guess that you all made and the answer that I had stored in the program, which was me. So there's the variables to store numbers. There was the idea that Andrea was holding on to. There's something known as conditionals or branching to test the guess. So this would be very much what you would be familiar from discrete as conditional statements. If this, then that. So that will help us consider branching. There's also ideas of input and output. You basically needed the input or the program to read input, and it needed to tell you something and to return. What other ideas kind of come to mind now that you've seen a few examples? Does anything come to mind of like what concepts were we working with? Not so much inductive thinking. Well, no, because inductive thinking is more proofs. There wasn't really a proof here. So the if statements are conditionals. Let me expound on that. So this would be like if, then. Did I stop? Did I just say, nope, you're wrong and walk away? No, I kept going. I kept repeating. So there's idea of repetition here. So which is the idea that you think about with like loops. You posed an interesting question. Kenneth, numbers were in play here. You thought about integers, but you asked could it be a decimal? In programming, decimals are typically referred to as floats or doubles. The phrase or the language Python uses is floats for floating point. And we'll talk about that in a few weeks about the issue with decimals when it comes to computers. Anyone think they know like why a computer does not like decimals? Think about pi. How long would it take to write pi? Forever, right? But a computer does not have infinite amount of storage. It remembers well, but there is still a limitation to it. There's also, there's a lot of ideas associated to words. Words are referred to as strings when it comes to programming. So if you hear me say a string, that is when I'm talking about words right here. There's a few other ideas. There's ideas of actions, which are functions. That's like, and it's kind of more of an encapsulation of the printing. And then let's see, is that really, so there's one other idea right here that we're going to talk about, and these are just some of the ideas. There's randomness. Every program you don't want, like it would be a pretty lame program if you said, what number do you want them to try and guess? You type 3 and then they're like, guess the number, like 3, you got it. So wouldn't it be nice if the computer could go ahead and generate some sort of randomness to make the game a little bit more interesting? So let's go ahead and let me just say what REPL is, since we've been using it. We're on REPL.com, or REPLit was his previous name. They changed it to REPLit.com. Let's go ahead and let me just say what that is, and then we'll go ahead and get to back to the programming. But that was a little bit of the setup of the course. Does anyone have any questions on anything we've talked about so far? Okay. So in that case, let me just go ahead and write this in here. So, all right. So I don't think anyone has used the word REPL in their life before, have they? It's not really a word, it's an acronym. So let me go ahead and put this up. So REPL stands for Read, Eval, Print, Loop. So read, eval, print, loop, or an interactive shell is a simple interactive computer program environment that takes a single user input, hence it reads it. It's kind of what we were doing. It was just taking a single input. It evaluates it. For example, is when I was saying too low, too high. And then it prints the result. And then it starts back over. So I say REPL. This is what is a REPL, is an environment where basically input is going to evaluate that input, it's going to print the result, and you're going to start back over. So basically, each little loop is a program in itself, and of course, we will want to combine some of those together. So let's go ahead and just talk about arithmetic operations a little bit more. So what I'm going to go to now is I'm going to go over to this console again. So let's go ahead and kind of get back to the console here. And the console is actually a REPL itself. So for example, let's go ahead and talk about some arithmetic operations. 3 plus 3 is going to be 6. So in this console, we can use the Python language as a, this is running a Python REPL right here. I'll kind of talk about kind of how I know that from a shell a little bit later. But let's go ahead and consider, everyone was like, oh, parentheses. So the Python language has all your basic standard order of operations. So let's say I have 3 plus 6. And by the way, to help you all out with the typing, let me see if this helps, if I can remember how to do this. Was it Control-Shift-Option? Hold on, let me do this. Checking one thing. Okay, never mind. I was going to try and get the key presses to show up. I'll figure it out later. All right, so what if we wanted to do 3 plus 6, but then we wanted to square it? What we would do to do an exponent is you would use 2 asterisks. Asterisks, you would have to go ahead and hit Shift and then hit 8 on the keyboard. So again, this is the point where I definitely encourage you to type along with me, just because these are the things that you're going to need to be in muscle memory. So what that expression right there is 2 plus 6 squared is going to be 81. So let's go ahead and consider division. So if you do, let's say we do 5 divided by 2, and the division symbol is just simply going to be the forward slash. Forward slash, I think about it's the way it's leaning. So you can see like the feet and then it's leaning forward. So it's a forward slash. So 5 divided by 2 is what? 2.5. But what if I were, okay, so let's think about this. 100 divided by 50 minus 1. Think about it a sec, then type it in and see if your guess was correct. So type it in, but think about it. Was your guess correct? So keep in mind, implied order of operations is it evaluates it as it goes. So it's going to do 100 divided by 50, and then it's going to subtract 1. So what do you all think this is supposed to give us? 1, but did it give us 1? Kind of. It gave us 1.0. So the reason it's doing that is because when you do division, it's basically going to give you a decimal answer, a floating answer, even if your answer was an integer. And we'll kind of talk about how the effects on that. But one thing to realize is when you divide, it's going to say, instead of giving you an integer, it's going to give you a float. And that is why there's going to be the 0.0, even though we don't necessarily need the 0.0. All right, so that is going to be the a little bit with the computation. So any questions on that console over here on the right? Yeah.
Where do you put spaces in between everything?
So I'm going to try to match kind of programming conventions so you don't have to. So for example, you could have done 100 divided by 50 minus 1, and it would have also done that right there. But a lot of conventions just help with readability, and that's one of those right there. So we'll talk about style guides and style recommendations as we progress through the course. But as I mentioned, you can see that the spacing is not necessary for the program to interpret or to evaluate this input. Okay, so any other questions? All right, so let's go ahead and make a new file and a new program. And what we're going to do is, actually before we do that, let's type one more thing. Let's take that same program, that Hello World program, which was just one simple line, one statement, and see if that also works here. And by the way, you may be like, you know what, we've already talked to the world. Maybe we want to talk to like the table. Hello, table. So you can see right there, it read it in the input, evaluated it, which was just the out, and then it gave the output right there. But let's go ahead and do one more thing with this before we write a new file. What if I type print, I put quotes and I say hello world, but let's say I forgot the last parentheses. And if I hit enter, look at how the line prompt changed from an arrow to a ... or an ellipses. That's saying, hey, I'm expecting more. Because if you think about this, functions, the parentheses are defining the input to a function. So I'm going to go ahead and finish off that and say, oh, okay, there's that right there. So if you're in the console and you see that ellipses, you probably forgot to close one of your parentheses. So parentheses come in pairs. Okay. So let's go ahead and let's go ahead and make another new file. So did everyone see where I could add a file up here in the upper left-hand corner? So let's go ahead and add a new file. And I'm going to go ahead and call this one hello.py. So let's go ahead and just see, let's go ahead and do it this way. So, hold on, I want to say. All right, so let's just see if this program's working. And I'm going to do hello Cody. I'm going to just talk to myself. So there's a little nuance about this environment I want to point out because it was a little confusing to me at first. So if you hit run, what are you expecting to get in the console? You're expecting to get hello Cody, right? But if I run this, notice I got hello world again. The reason that is the case is because this button up here, this run button, is tied to main.py. We'll talk about libraries and modulators in this semester, and you want to have an entry point into that, and that's typically a file called main.py. So we're doing another one. So how do I run this? So what we're going to do is go to the shell. The shell is, for those of you who may have messed around on a Mac, is your terminal, or if on a Windows, your command prompt. Do you know, like in the movies where they're like, it's just a black and white screen and there's text and they're typing a bunch of commands? That's what this is. So what this is telling me is that I'm in the directory or the folder day-01. The way I can tell that is if I type ls, which is short for list, it's going to go ahead and print all of the files that are in that folder. So this is, again, just some basic navigation through a kind of a non-GUI or a non-graphical graphical user interface. But you can see those are the 3 files that we see listed over here. Everyone okay with that? So how do I run the one that's specifically hello.py? Well, it is a Python program, so I'm going to go ahead and write Python. And then I'm going to go ahead and type hello.py. And that is how you would run a program that wasn't, in this environment, that wasn't titled hello or that was not titled main.py. All right. Any questions there? Okay, so let's go ahead and introduce one more idea today. Let me see. Okay. And that is that of a variable. So I'm going to go back to hello. But let's go ahead. I'm going to go ahead and just kind of delete this, start over. I want to introduce the idea of a variable. So notice a variable is I'm going to just call this variable name. You can call it X if you want, but standard convention is to go ahead and name your variables something that is indicative of what they are. So I'm going to go ahead and name this variable name. So in programming, it could be more than one letter or more than one symbol. And to assign or to bind a value to that variable, I'm going to go ahead and use the binding or the assignment operator, which is simply the equal to sign. And I'm going to go ahead and put name. Okay. And then what I'll go ahead and do is print the variable name. Notice the variable, this time the print does not have the quotations. And just to compare, I'm going to go ahead and put a second print statement here that is name with quotes. So the first line, on line 2, the print with name in parentheses is going to be the variable, is going to print what's stored in that variable. The second one is just going to print the string name. And again, how do we go ahead and run this? Do I hit the button? No. By the way, shortcut, if you want to repeat the previous command, just press the up button. So if you press the up button in the shell, it will go ahead and put in the last command, hit enter, and you can see it first printed on one line Cody, then it printed on the next line name. So that is the introduction to variables. So let's end today with just kind of a little bit of a little exercise. So what I'm going to go ahead and do is introduce the let's just do it this way. Let's see what happens. You could also do computations within print. So let's say X. What is someone's favorite number? 7. That seems to be the most common favorite number right there. All right. What is someone else's favorite number? Let's call it Y. You're math majors. I know you all like numbers. Caroline, what's your number? Favorite? 16. So I have 2 variables. And notice I could print X plus Y. And if we go ahead and run that, again by pressing up, you can see right there, it did the computation to go ahead and work with that. So that is the kind of the basic setup for this platform, just some basic exercises that we just did to kind of wrap our minds around it. We have a little bit more to learn about printing and variables and things like that, but does anyone have any questions on what we discussed today? Okay, so then the last thing I'm going to say in this, or we're pretty much out of time, but just if you're exploring, feel free to go ahead and do so. The other thing you'll see is under Teams, and then you'll find the course that we're now enrolled in, and then this is where you'll find exercises. So like at the very bottom, you're going to see some programming exercises. I'm going to release a project either later this week or earlier this weekend. So you can see right here, their exercises are worth different amounts of points. I would encourage you to maybe just look at the tutorial one. We'll talk about it a little bit more on Monday. Not Monday, Friday first, right? Okay, so that's our first class. Does anyone have any questions? Okay, if you have questions, feel free to stick around. Otherwise, have a great first day of classes, and I will see you all on Friday.